Welcome again. We'll be covering two questions today as well. So first question, we have two trains, 100 meters and 80 meters in length, respectively, are running in opposite directions on parallel tracks. Their speeds are 45 km per hour and 30 km per hour, respectively. In what time will they clear each other from the moment they meet? So basically crossing each other. This is a concept that we discussed in the previous video. So we have two objects, 100 meters in length, the other 80 meters in length. Crossing or passing implies the distance or the relative distance. In this case, it would be relative distance because both are moving, would be 180 meters to be covered, sum of the lengths of the two objects. Now, because they're moving in opposite directions, so the relative speed would be 45 plus 30, that is 75 km per hour. Just convert it to meter per second because this is in meters and just calculate. So let me just briefly show the calculation. 75 by 18, you have some cancellation out here. You can cancel 3. So you have 25 into 5 remaining, that is 125 by 6. This would be the speed in meter per second, sorry. And that gives us the time, the required time, let's say. That would be distance upon the speed in seconds. Let me just briefly calculate this on 180, 125. I can show you one small trick out here. 125, if I take 4/5 of this, I get 100. If you are good with calculation, basic calculation tricks, you'll understand this. Because dividing by 100 is no challenge at all, right? So just divide the denominator, or make the denominator 100 by taking 4/5 of it. To make the equivalent adjustment in the numerator, you should also take 4/5. 4/5 is basically 1/5 removed. So 180's 1/5 is 36. Remove that, you get 144. Cross 6, 140 cross 6 is 840, and 4 cross 6 is 24. So you get 864. This much seconds, which is, as you can see, very easy to calculate. So that's the answer for this question. Let's look at the next one. A train passes two persons walking at the rate of 5 km per hour and 10 km per hour, respectively, in the same direction in which the train is going in 6 and 8 seconds. Now, the train is passing two people. In each of the cases, when it passes the individual person, it would cover its own length because the person would be a point, right? An insignificant number. So let us say that length is not given out here. So let us consider the length to be in meters. So let us say the train's length is L meters. This is the distance that the train has to cover, relative distance as well. So let us just assume the speed of the train to be some t kilometer per hour. So I'm keeping a parity between the speed unit as of now, and then we'll make the conversion accordingly. So what happens for the first man? So the first man is traveling 5 km per hour and it's moving in the same direction, right? Both of them are moving in the same direction in which the train is going. So the relative speed of the train with respect to the man would be t minus 5, right? Every hour, the train moves t kilometers, but the man covers 5 kilometers. So the offset is t minus 5, right? That is how much the gap would reduce, something like that. So in the first man's case, we have t minus 5 km per hour. Let's convert that to meter per second. And it covers in 6 seconds, right? Now, what did it cover? So this is the speed. And this is the time. So speed into time is the distance. And what is the distance or the relative distance that the train is actually covering? That is its own length, the length L meters that we have assumed. Now, in the second scenario, so we have train speed t, 10 km per hour, same idea, same direction. So we have t minus 10 converted to meter per second. This is the speed, time 8 seconds. That should also be the same distance, right? In both the cases, the train is covering a relative distance of its own length. The first thing that you do is solve this part. A lot of ways to solve this. So let me just cancel this out first. You can just open the bracket. But if you are moving ahead with time and distance problems, at one point of time, you would be able to write this straight away without writing any of these. So what I mean by that is, in the first scenario, the relative speed is t minus 5. In the second scenario, the relative speed is t minus 10. In the first scenario, the time is 6 seconds. In the second scenario, the time is 8 seconds. The distance remaining constant, and the distance is constant because the train is covering its own length in both the scenarios. The distance remaining constant, the speeds are inversely proportional to time. So t minus 5 upon t minus 10 should be equal to 8/6 inverse proportionality. So you can write this straight away without framing this. So why am I showing you in this way? I'm pretty sure everybody can open the bracket and solve this. But if you have written in this way directly using the proportionality, then you actually don't have to do this. Even you can just reduce this to 4/3 to begin with. Now, notice that there's a gap of 5 irrespective of the value of t, right? There's a gap of 5 between the numerator and denominator here. And there's a gap of 1 between the numerator and denominator here. To make an equivalent graph, I have to multiply 5 to the numerator and denominator. So I get 20/15. The advantage, now I can simply equate the numerator. So t minus 5 is 20. So t comes out to be 25. And remember, we have considered t to be in kilometer per hour. So this is 25 kilometers per hour. That is the first part, speed of the train. What about the second part? Use either one of them. So we have, for example, in the first scenario, 20 kilometers per hour, traveling with the speed of 5/80, covering in 6 seconds. So just use this. You have the length of the train as these many meters. So this is 100/3. It's roughly 33.33 meters. So that's it for this question. I hope this was understood. And that's it for today. Let's meet in the next video. Thank you, everybody, for joining. If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.